My name is Kevin Jessen lubis. I'm from Metalurgi, from Mechanical Engineering University, Udayana University. Now I want to present my PowerPoint, Discovering Metals, a historical overview. 6 metals were used by prehistoric man: gold, silver, copper, tin, lead, and iron. Gold and silver were too soft to be useful for much expert decoration. Copper could be hardened by hammering or forging and was therefore useful as a tool but had little value as a weapon. Bronze, developed by alloying copper with tin, had useful strengths, could be hardened by forging, and could be caused to shake. This discovery of bronze significantly altered the development of civilization. Lead was soft, easily worked, and could be made into vessels. Later in history, it was made into pipes, such as those used to transport water in the early Roman Empire. Iron was so important to civilization that its discovery led to the Iron Age and a transition from the Bronze Age. First, native metals. Most metals naturally occur as minerals or compounds. The metal atoms have reached with other metals or with non-metallic atoms. One of the primary tasks of the metallurgist is to extract the metal from the compound. The few metals that are found in an unreached state are termed native metals. This is the picture of chronological list of the developments in the use of materials. Next, the Bronze Age. The Bronze Age began when it was discovered that mixtures of two metals or alloys were stronger than either of metals taken individually. This discovery was probably made about the same time the extractive metallurgy was discovered. The discovery then tin allow addition strength than copper was the crux of the Bronze Age. The chemical analysis of a typical bronze alloy from the ancient Middle Ages showed that the alloy contains approximately 87% copper, 10 to 11% tin, and small amounts less than 1% of iron, nickel, lead, arsenic, and antimony. Low-tin bronze was probably produced because of the difficulty in locating good supplies of tin. Tin-rich ores were not as common as copper-rich ores. Frequently, tin had to be transported of the large distance. Because of the date problems, bronze was an expensive material and unalloyed copper was probably used when it was practical. The metals were used in farming and domestic quarters did not require strength as high-class metals for use in hunting and fighting. Even during the Bronze Age, there were material shortages and tin was a critical material. Next, making metals extractive practice. Minerals are frequently brightly colored, iridescent, and attractive. Because of such attractiveness, cements and modern minerals well collects mineral samples. For example, a typical copper containing sulfate mineral is bornite, which contains copper or Ti. iron and sulfur in the ratio of 5 sulfur atoms to 1 iron atom to 4 sulfur atom, designated as Cu5PeS4. This ore is reddish or reddish purple when freshly broken and becomes iridescent blue or blue-green when exposed to the atmosphere. This is changed in color, tarnishing due at atmospheric exposure results from the chemical reaction of the ore with oxygen in the atmosphere. Chalcopyrite is a yellow copper sulfide ore that also contains iron, while copperite is a deep blue copper ore that contains only copper and sulfur. Pyrometallurgy is the extraction of a metal from ores by chemical reaction at high temperatures in full-fired furnace. Pyrometallurgy may involve roasting and or smelting for the extraction or refinement of metals. Smelting refers to melting process that separate metals in fused form from non-metallic materials. Other more modern methods of extraction and refinement include hydrometallurgy and electrometallurgy. Hydrometallurgy is the leaching or removal of the metal from an ore body by passing of the strongly acidic or alkaline solution over the ore. Electrometallurgy involves the extraction of metals from their ores by the application of large amounts of electrical energy. This is a picture of common occurrence of metals: carbonates, fluorides, halides, native metals, oxides, phosphates, silicates, sulfates, sulfides, miscellaneous. Next, iron. The first iron to be developed was wrought iron. Wrought iron can readily be forged to shape. In fact, the term wrought means to shape by hammering or beating. Wrought iron is very ductile for forging because it contains very little carbon, less than 0%. Carbon is an interstitial impurity that strengthens the iron lattice. In fact, iron alloys that contain between approximately 0.1 and 2% C have a special name steels iron smelting. As with the reduction of copper sulfide ores, the first reduction of iron oxide was probably accidental. It was the powers of observation that led the ancient metallurgists, who also served as the miners, shamans, and technologists of their day, to realize that iron could be produced in simple furnaces by direct carbon reduction of the oxide ore. The exact date of the first international reduction of iron cannot be established, but it is certain that the making and shaping of iron was widespread in Egypt by 1500 BC. For the next 3000 years, techniques for the production of iron did not significantly change. Iron sponge was produced by carbon reduction of the oxides. Iron products were made by punching the sponge. Iron oxides are present in many areas of the earth. Thus, roughly at the same time, ancient man was reducing iron ore in Egypt. It also was being done in other areas. China, India, Africa, and Malaya served as sites for this initial development of iron making practice. It is perhaps significant that the furnace developed in the countries were all quite similar. There were differences in shape and size, but we furnaces were functionally identical. The chemical reduction to iron occurred without melting, and the resulting metal was relatively pure and soft. It could be hammered into useful shapes and was termed wrought iron. Next, discovery of modern metals. Some of the commercial use of several of the metals are described subsequently. Beryllium is added to copper to improve its strength. The mechanism or process by which beryllium increases the strength of copper is very different than the strengthening that results by zinc or zinc's addition to copper. 2. Cadmium was discovered in 1817 and is primarily found in zinc ores. Cadmium coating or platings were used to protect nuts, bolts, and other components made of high-strength steel or other corrosion from metals. Chromium was discovered in 1798 and is used mainly as an alloy addition in steel production. Chromium improves the resistance of steels to oxidation and corrosion and is an essential ingredient in stainless steels. For molybdenum was discovered in 1781 and is primarily used as an alloy addition to steels. However, molybdenum melts at 2620 degrees Celsius or 4750 degrees Fahrenheit compared to 1535 degrees Celsius or 2795 degrees Fahrenheit for iron. This difference in melting temperature complicates in combining two metals into an alloy. 5. Tungsten was first refined from ore in 1783 and was originally called wolframium. Tungsten was first used as the filament for the incandescent light bulb, and this use accounts for 15 to 20% of all tungsten use. 6. Vanadium is among the hardest of relatively poor metals. It was discovered in 1830 and is actually more abundant than copper, nickel, or zinc, but is very difficult to purify. 7. Magnesium is the lightest of the widely used structural metals. Magnesium is more than 1/3 lighter than aluminum, having a density of compared to the density of aluminum. Because of its low density, magnesium has been used in aircraft frames. It is also an important alloying element in aluminum. 8. Titanium was discovered of 1790, but because of the difficulty of freeing titanium from oxygen and nitrogen, it was not readily available as a structural material until the 940. 9. Iridium, rhodium, palladium, and platinum are, along with gold, termed the precious metals. They are all very dense and very corrosion resistant. However, the terms precious metals come from the fact that all these metals are expensive. Last, aluminium, the third most abundant element. The face of the Earth is a member of the family of metals that includes gallium, indium, and thallium. Refining of metals. Refining of metals refers to process that purify extracted metals. Refining of metals, like the extraction of metal from ores, includes many ancient practices and more modern advances. For example, gold always occurs in the metallic state, and it can be extracted from minerals by relatively simple means. That is, panning and slashing for gold effectively separates the gold from minerals such as sand or gravel, because the density of gold is much higher than that of minerals. For example, the quartz in sand has a density of approximately. Panning and slashing with water wash away like sediment from gold or nuggets or flakes. Refining techniques for much metals are much more complicated but involve similar phenomena. Many techniques now used were not developed until quite recent times. Today, refining can be used to produce very pure metals. Copper, gold, silver, aluminum, iron, and many other metals can be purged at the purified levels of 99.99, which is equivalent to 1 part impurity in a million. This is my presentation. Thank you for watching. See you. Bye.